Hello everyone, myself Pragna from 4th Sem Engineering here to explain you about the topic of graph theory. Graph theory. Graph theory was first introduced by the Swiss mathematician Euler in year 1736 in his solution to the famous seven bridges of Konsberg problem. The field continued to develop throughout the 19th and 20th centuries with notable contributions from mathematicians such as Arthur, James and Paul. Graph theory. In mathematics, graph theory is the study of graph, which are mathematical structure used to model pairwise relationship between objects. A graph in this context is made up of vertices which are connected by edges. A distinction is made between the undirected graph where edges link two vertices symmetrically and directed graph where edges link two vertices asymmetrically. Graphs are one of the principal objects of study in discrete mathematics. Importance of graph theory. Graph theory has applications far beyond the world of discrete mathematics. For instance, much of the computer science operates through the usage of graph algorithm and data structures. Chain of code operates like the vertices, edges of a graph. As a user interacts with software, they engage in a form of graph traversal. Business people, economists, and financial professionals also use graphs to depict data points. Although the graph for such circumstances might be simpler than those in use by mathematicians in advanced graph theory, they still operate off the same basic principles. What is a graph? A graph is a non-linear data structure consisting of vertices and edges. The vertices are sometimes also referred to as nodes, and the edges are lines or arcs that connect any two nodes in a graph. More formally, a graph is composed of set of vertices and set of edges. The graph is denoted by G in braces E and V. Components of a graph: vertices and edges. Vertices. Vertices are the fundamental unit of the graph. Sometimes vertices are also known as vertex or nodes. Edges. Edges are drawn or used to connect nodes of the graph. It can be ordered pair of nodes in a directed graph. Edges can connect any two nodes in any possible way. There are no rules. Sometimes edges are also known as arcs. For every edge can be labeled or not. Basic concepts of graph. Graph. A graph is a mathematical structure consisting of a set of points called as vertices and a set of lines linking some of the pair of vertices. Loops and multiple edges. A loop in a edge that connects a vertex to itself. If a graph has more than one edge joining some pair of vertices, then these edges are called as multiple edges. Simple graph. A simple graph is a graph that does not have more than one edge between any two vertices, and no edge starts and ends at the same vertex. Adjacent vertices. Two vertices are said to be adjacent if there is an edge connecting to them. Adjacent edges. Adjacent edges are the edges that share a common vertex. Degree of vertex. The degree of vertex is the number of edges incident with the vertex. Path. A path is a sequence of vertices with the property that each vertex in the sequence is adjacent to the vertex next to it. Cycle. A circuit that does not repeat vertices is called as a cycle. Connected graph. A graph is said to be connected if any two of its vertices are joined by a path. A graph that is not connected is a disconnected graph. Bridge. A bridge is an edge whose deletion from a graph increases the number of components in the graph. If a graph was a connected graph, then the removal of the bridge end disconnects it. Types of graph: directed graph and undirected graph. Directed graph. In directed graph, the edges direct the path that must be taken to travel between the connected nodes. Undirected graph. Undirected graph does not show the direction which must be between the nodes. Graph representation. Adjacent matrix and adjacent list. An adjacent matrix is a compact way to represent the structure of the finite graph. Adjacency list. The adjacency list represents a graph as an array of linked list. The index of the array represents a vertex and each element in its linked list represents the other vertex that form an edge with the vertex. Applications of graph in computer science engineering. Data structure, network analysis, algorithms, and social networking. Data structure. Graphs are fundamental data structures used to represent various relationship and dependency. Trees, a specific type of graph, are used in many algorithms and data storage structures. Network analysis. In computer network, graph theory helps analyze connectivity, finds bottleneck, and optimizes data transmission. Algorithm. Many algorithms like Dijkstra's algorithm for finding the shortest path and Crucial's algorithm for finding the minimum spanning tree are based on the graph theory concepts. Social networking. Social media platform uses graph theory to model and analyze user connection, enabling friend recommendations and targeting advertising. Transportation, route optimization, traffic engineering, supply chain management. Graph theory is used to find the most effective route for transportation. Traffic engineering, transporting engineers use graph to model road networks, analyze the traffic flow, and optimize signal timing. Supply chain management. Graphs help model complex supply chain network, allowing for efficient production and distribution. Biology. Genetic interaction network. Graphs represent relationship between genes and proteins in biological system, helping biologists understand complex interactions. Phylogenetics. Phylogenetics trees a graph, a type of a graph depicts the evolutionary relationship between the species. Epidermology. Graph theory is used to model the spread of diseases in populations. Social networking. Social network analysis. Graph theory is used to study social structure, friendships, collaboration, and influence people propagation in various social networks. Opinion dynamics. It helps analyze how opinions and behavior spread within a society. Linguistic and natural language processing. Semantic networks. Graphs are used to represent relationship between words or concepts, aiding in natural language understanding and machine translation. Document similarity. Text documents can be represented as graph, making it easier to compare their contents. Chemistry and material science. Chemical components. Chemical structures are often represented as molecular graph, helps chemists understand molecular property and reactions. Material science. Graph theory helps model and analyze the structure and properties of materials such as crystal lattices. Recommendation system. Collaborative filtering. Recommendation systems use graph to model user item interactions and suggest product movies or music based on similar user preferences. Urban planning. City planning graphs model urban infrastructure such as road networking, public transportation system, and utility grids, etc. Thank you.